Now in this video we will be reviewing over energy and its relation to the metric system. Now specifically we will be looking at kinetic energy and gravitational potential energy and how to solve problems dealing with each. Now we'll begin with the kinetic energy. The metric unit for energy is the joule. And as we look at kinetic energy is energy of motion. And so as we calculate kinetic energy for various physical science setups, the units for kinetic energy will be joule, and the formula used will be kinetic energy equals 1/2 mass times velocity squared. The mass will typically be in kilograms or grams, and the velocity will typically be in meters per second squared. Now, what we're going to be doing on this particular video is looking at how do we solve for each of these and how do we identify what is given in a physical science problem and what's left for us to solve for. Most of our physical science problems will be simple algebraic problems where two of the components will be given from the problem and one will be left for us to solve for. Now here we have a kinetic energy problem. A crow with a mass of 3 kilograms starts to chase a hawk and flies at a velocity of 6 meters per second. What is his kinetic energy? Well, in order to solve this problem, we must first remember that our kinetic energy is going to equal 1/2 mass times velocity squared. Now we are given a mass of 3 kilograms, a velocity of 6 meters, and the kinetic energy is our unknown. So here we have our formula, kinetic energy equals 1/2 mass times velocity squared. And so we plug in our numbers, and we solve for x, and we would get our kinetic energy as being 54 joules. Now, before we move on to any additional problems, let's just talk about kinetic energy for a moment. Remember that kinetic energy is the energy of motion, and the chemical formula for kinetic energy is kinetic energy equals 1/2 mass times velocity squared. So kinetic energy is affected by the mass of an object and the velocity that the object is going. If the mass of the object is doubled, then the kinetic energy would be doubled. However, if the velocity of the object is doubled, the kinetic energy would be quadrupled. So do be aware that between mass and velocity, velocity has the greatest effect on kinetic energy. To prove that point, we've just set up this slide. What is the kinetic energy of an object with a mass of 10 kilograms and a velocity of 10 meters per second? Well, we have our formula, kinetic energy equals 1/2 mass times velocity squared. We plug our numbers in, we solve, and we would get the kinetic energy as being 500 joules. Well, what about if the mass was doubled? And so instead of being 10 kilograms, we have it as 20 kilograms. So we would get 1/2 times 20 times 100, and we would get our kinetic energy as being 1000 joules. Therefore, if our mass is doubled, our kinetic energy is doubled. But what if our velocity was doubled? So instead of 10 meters per second, we're looking at 20 meters per second. So again, we have our 10 grams times 20 meters per second times 1/2. Solve, we would get 2000 joules. So just to show you that between the two, velocity has the greatest effect on kinetic energy. In addition to kinetic energy, we also have gravitational potential energy. Now, gravitational potential energy is also measured in joules, and to calculate gravitational potential energy, we take the mass of the object in kilograms or grams times the acceleration of gravity in meters per second squared times the height of the object. Now, if we look at the characteristics that affect gravitational potential energy, according to the equation for gravitational potential energy of an object increases as the height increases. But what if the height of two objects is the same? Well, the gravitational pull will also be the same, So mass would have the effect. The larger mass would have more gravitational potential energy. Here we have a gravitational potential energy problem. A 3 kilogram crow is perched on a tree limb 20 meters above the ground. What is the crow's gravitational potential energy? Now, gravitational potential energy is going to be the mass times the height times the gravitational pull. Now we have the mass as being 3 kilograms, we have the height as being 20 meters. The pull of gravity is set. It is a constant, it's 9.8 meters per second squared. And so we would take our 3 times our 20 times our 9.8 meters per second squared, and we would have a gravitational potential energy of 588 joules.